me again. This is a lesson about the greatest common factor. Greatest common factor is very helpful when reducing fractions, which was the last video in the last lesson. So this correlates to lesson 82 in the Saxon book. But the greatest common factor is covers a couple of different things, and we need to think about vocabulary. So we know greatest is the best, the biggest, the most, right? Greatest, your greatest accomplishment, your greatest feat, right? All these great things. Common really is something that we have in common, right? So it could be common between numbers, it could be common between people. I have brown hair. Some of you have brown hair. We have that in common. I have a beard. You do not. So we do not have that in common. So common is something between us. And then factor, we've talked about a bunch this year, but it's always a tricky one because it's just a weird word. But really think about the word fact. When we're practicing our math facts, we think about multiplication, really. So factors are, again, those numbers. If I do 3 times 5 equals 15. Our factors really are the numbers that multiply together to equal a product, right? This is the product, or, well, it's just the product. So they multiply together to equal a product. So if I say, what's a factor of 15? I could say, well, 3 is a factor of 15, or 5 is a factor of 15, because it goes in evenly. Remember, factors are always smaller than that number or the same thing. And that's important because 15 could also be, I'll just do 15 times 1 equals 15. So we know that 15 is a factor of 15 as well. 1 is a factor. So whenever we're thinking about factors, the first two, 1 and the number that we're doing. So greatest common factor. Now, if we have a common thing, then it has to be two things that we're talking about, right? If there's something common, then we need to have two numbers. So if we think about what is the greatest common factor between two numbers, that's what we're looking for. So if we think about, let's say, 4 and 6, okay? I'm gonna set it up like this because what I'm gonna do is I'm gonna create a box. Well, and this is just to kind of highlight it for you guys. Don't make boxes yourselves because that would be a lot of extra writing. But just to kind of separate it, I'm gonna find the factors of 4 and 6, and I'm just gonna say this from the beginning. What I like to do is always just start from the beginning, right? Start at 1. We know that 1 multiplies into anything, right? So, and I like to spread them out, so I like to have and this is what they actually recommend, Saxon does, is that you have 1 be at the beginning and then the number, right? So in this example, 4 would be the end. So I know that 1, right, and 4 are factors of 4. 1 times 4 equals 4. So I know that they're factors. Remember this? We've talked about this. Okay, so are there any other factors for 4? Now, again, multiplication facts are really going to help you when knowing your factors, right? The more practice you get. So keep trying that. Reflex, keep practicing your math facts at home. It really will help. Use the card games that we do and the other stuff to help you with your math facts. Okay, so are there other numbers that multiply together to equal 4? And yes, there are. We have 2 times 2 equals 4. Now, I know that 2 is a factor, but I don't need to write it twice because 2 is the factor, so we just keep it at that. So my factors for 4 are 1, 2, and 4. Okay, so now let's do 6. And again, start at the beginning. 1, I know 1 times 6 equals 6. Okay, so what else equals 6? Well, I know that 2 times 3 equals 6. That's another way to multiply and get 6, right? 6 is going to be the product. We want to find what numbers multiply together to equal that. So I need to put these two numbers now up here because those are my factors. So 1, 2, 3, and 6. Okay, so now we have the factors for 4 and we've got the factors for 6. So now we need to find the greatest, biggest, common that they have in common factor for both of these numbers, greatest common factor, okay? So in this example, 1's a common factor, 2's a common factor, 3 is not, 6 is not. So my common factor is 2. All right, so greatest common factor for the numbers 4 and 6 are 2. Now, why is this important for reducing fractions? Well, if you remember from the video, we would pick the numbers as we went along and find numbers that went into each number, and that's kind of how we did it. Well, if we use the greatest common factor, we'll be able to find the biggest number that goes into each, okay? And that's important because then you have to, you can skip that middle when you didn't get it to the lowest terms. If we get the greatest common factor, we'll reduce the fraction to its lowest terms immediately. We don't have to have the extra steps. So what does that mean? So if we take 4 6, and here's that example, right? Here are the numbers 4, 6 down here. And remember, in reducing fractions, we're dividing by a fraction equal to 1. Okay, dividing. And so what is my fraction? Well, my greatest common factor is 2. So that's what's going to be on the top and bottom of the fraction I'm going to divide by, right? So remember, this is making an equivalent fraction and is bringing it to its lowest terms. So I'm going to be bringing it completely to its lowest terms because I know that this is the greatest common factor between 4 and 6, because I just calculated it all. So 4 divided by 2 is 2. 6 divided by 2 is 3. And there is my reduced fraction in its lowest terms. But let's get a little bit crazy here. 4/6 is a beautiful fraction, but we can show you with a little bit more complicated. And you will have some practice with the IXL, and feel free to look over this again. I'm also going to link a Khan Academy a lesson just to have another one, if another perspective and way to explain it, if you'd like. But here we go. Let's do something. How about 12? I'm going to do the fraction 12. How about 36? 12/36. Now, when I first was talking about reducing fractions, we were like, oh, let's just go and, oh, they're both even. We can cut them in half, right? Well, let's find the greatest common factor of these two numbers and see if there's a bigger number that goes in. So I'm going to start with 12 and 36. We're going to go. Okay, so starting off with 12, I know that it starts. I can do my boxes if I want to, or you can just write it out. I'll do the boxes just for fun. So I know that 1 and 12 and 1 and 36 are always going to be factors that go in because we have the 1 and the last number. Now here it can get a little tricky, especially with 36. So does 2 go into 12? Well, 12 is even, so yes. So 2 times what equals 12? Well, 2 times 6 equals 12. What else goes into 12? Does 3 go into 12? 3, 6, 9, 12. Yes, 3 goes into 12 4 times. So, because 3, oh, that's not what I wanted to write. 3 times 4, 6 times 2, and 1 times 12. Those are my factors for 12. Okay, all the factors right there. All right, now let's do 36. 36 is going to be a little bit trickier. Okay, I know that 1 times 36. Now, 36 is even, so I know that 2 is going to be able to go into it. But what is that number? Well, the way I'm going to probably figure it out is I know that 30 cut in half, because we're just cutting 36 in half. 30 cut in half equals 15, just like half of a, it's like quarter of an hour if we think about minutes. And then I have 6 cut in half is 3. So I put those together, 15 and 13 equals 18. So that's probably how I would calculate cutting 36 in half. I'd cut 30 in half and then 6 and put them together. Nice that numbers, you can do that. So now 18 goes up here. So 2 times 18. So I'm going to write all my factors. 36 times 1, 18 times 2. All right, does 3 go in? 3 goes into 36. Well, let's think about that. I'm going to just divide it because that will tell me. Oh, I can't even see it. 3 goes into 36. 3 goes into 3 one time, which is 3. Subtract 0. Bring 6. I don't know why I'm whispering, but I am. 3 goes into 6 2 times. Oh, yeah, duh. 3 times 12 is 36. What am I thinking? So I know that 3 does go in, and it goes in 12 times, okay? 12 times 3 equals 36, 36, 36. Okay, anything else? Let's see, does 4 go into 36? Yes, it does. And what is that? Well, I know my math facts, so I know that 4 times 9 equals 36. So I have a 4 here. Uh-oh, I'm running out of space. I'm just going to put it way up here. 9, because I want to, I mean, I guess I could fit it in there, but do I have any more? Let's see, does 5 go in? Well, 5, it would have to end in either 5 or a 0, so no, that doesn't work. What about 6? Oh, yeah, 6, because 6 times 6 equals 36, okay? So these are all of my factors right here, okay? These are my factors, and so I have, that's a 6. 1, 2, 3, 4, 6, 9, 12, 18, 36. Whoa, crazy. So this is a lot of work, right, to find the greatest common factor. We have to really do it. Eventually, with your math facts being dialed in and you like don't even have to think about it, these will just pop up and you'll be able to do it on your own without needing to go through this process. But this is the nice, easiest way to make sure that you get it. So we've got things in common. We've got 1 in common, 2 in common, 3 in common, 4 in common, 2 in common. I'm funny. 6 in common. Oh, look, but we do have a 12 here, and then that's the last number. So 12 goes into both evenly. Interesting. So I'm going to just get rid of this, and I'm going to go back to my fraction, which is 12 over 36. So I'm reducing. Remember, greatest common factor, we're using greatest common factor to help us reduce. So I just found out that the greatest common factor of 12 and 36 is 12. Oh yeah. So to do the greatest common factor, we're just going to now reduce by dividing by both. Okay, that was from the last lesson. Greatest common factor is 12. 12 12s is the same as 1, right? We know that. So I'm just dividing by 1. So 12 36 divided by 1. 12 divided by 12 equals 1. 36 divided by 12 equals 12, 24, 36. If I count by 12s, just double it. Lowest terms. We made it. We made it through. All right. Greatest common factor. You're working on finding that number that is the biggest that they have in common, okay, between two numbers. That's going to help us do our reducing and get you rolling. So, again, if you have questions, please feel free to reach out to me, and I'm going to have some Zoom times to be able to connect with you guys and work on this one-on-one. But other than that, good luck on the IXL activity, and we'll talk to you guys soon. All right, bye-bye.